Hi. So we'll start with the summary of week 5.
Good evening, ma'am.
Good evening. Let me just share my screen.
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt. Can I ask, ma'am?
Yeah.
Ma'am, will the exams have questions with no choice, like most?
Your voice is not clear.
Ma'am, will the exams have questions with no choice more often, ma'am?
Questions from where?
Questions with no choice, ma'am. With no options.
Sorry, I can't hear you. Can you, or you can drop your doubt in the chat box if that's possible.
Hello, ma'am.
Yeah.
Ma'am, this is my qualifier. I am not a term student. So in calendar, the meeting links are showing. So can I attend this?
Yeah, I think you can.
Okay. Okay, ma'am.
Can we start with the session?
Yes. Yes, ma'am. Please.
Okay. So we're discussing week 5 today. Week 5 majorly is about one functions, your composition functions, and yeah, one functions, composition functions, and then inverses. That's what it is about. So that's what we're going to discuss. Uh, so let's start with one functions first, called one-to-one functions or one functions. So one-to-one functions are basically where defining it, it means f is said to be a one function if at all you get this thing fx1 equals fx2. This should imply that x1 is equals to x2. So if you have a function such that whenever fx1 is equals to fx2 for some x1 x2 belonging to the domain, this is d. I'm denoting the domain by d. So if that happens, then your x1 and x2 should be equal. For example, if you have x plus 1, that's never going to happen here. That's also one of the ways how you check one functions. Is the definition clear? This is the definition where you say that your function is one if whenever two values of the function at two different points are same, then those 2 points are also same. That means, in other words, at two different points in domain, f cannot be same. In simple word, it means this. And by definition, it means this. That if whenever at 2 points you get the same value, your points should be same. So if the function's value at 2 points is same, then the point as well should be same. Then how do we check if a function is one or not? So there are ways to check it. The first way is your ways or test, whatever you call it. So first is your graphical method, which is your horizontal line test. So in horizontal line test, what you do is, graphically what happens is, let's just say you have this function, and on the other hand, you have this function. So what happens here is, at the if you draw a horizontal line here or anywhere, here, anywhere in the on the y-axis, at most it's going to cut this graph at one point, right? It only cuts it at one point. If you draw vertical lines here in this graph, this horizontal line cuts the graph at 3 points. Here it cuts at again 3 points. So what happens is, if you draw a horizontal line and your graph gets cut by the horizontal line at more than 1 point, then it's not a 1 1 function, right? Because this is not, because here for 2x, this is 1x, let's call it x2, and let's call this one x1. So for two different x, you're getting the same fx, right?
Ma'am, what you have written above in the
That's why
bracket
this
at
is
two.
not a 1 1 function, not a 1 1 function, because at two different points in domain of fx.
Can't be
So
same, ma'am.
if
What
you
does
have
this mean?
two different points in domain obviously of fx, then you cannot have, then your fx can't be 1 1. What?
Ma'am, that means we don't have two
Okay,
different
sorry.
image of
Can't
y.
be. Yeah, I had written something else. At
Ma'am,
two
your voice
different
is not
points in
clear.
domain, fx can't be same. Yeah, right. Sorry, what?
Ma'am,
Ma'am, your
actually,
voice
your
is.
voice is
Your
breaking,
voice is not clear, ma'am.
Is
in
it better
between.
now? Is it fine?
Yes, ma'am. Yes, ma'am.
Okay, has it been this way from, is it fine now? Is my voice fine now? Is it still breaking?
Yes, ma'am. Yes,
No,
ma'am.
ma'am,
It's
now
fine
it's
now.
okay.
It's fine.
Am I audible?
Yes, ma'am.
Ma'am,
So,
what I was saying is at two different points in domain, there is two different values of y. Does it means that?
yeah, that's what I've written. Fx can't be same. So two different points in the domain, if you have, then your fx cannot be same at those 2 points for it to be 1 1 function.
Okay, ma'am.
So you can also say for two different points,
Ma'am,
your
again, your
function
voice
should
is
give
not
two different
clear.
values. That's also correct.
Ma'am, your
It's
voice
jarring
is
in between
breaking
the
in between.
concepts when you
Okay,
are
give me a minute.
speaking.
But ma'am, in activity question there is a quadratic equation and it is correct, ma'am. Ma'am, this
What's correct is, firstly, about my voice, is it still breaking?
sometimes
Yeah,
ma'am in
ma'am.
critical word when
Yes,
you
ma'am.
yes,
Ma'am, I think there is some network issue from maybe your end.
Yeah, just give me 1 minute then.
Yes, ma'am, because if we say to you anything, so you're getting delayed voice.
Just give me 1 minute to fix this thing. Is it fine now?
Yes, ma'am.
Can you guys hear me? Is it
Yes, ma'am.
fine now?
Yes,
Yes.
ma'am, it is fine.
Okay. So I hope the definition is clear, the definition of one function. And then we were discussing how do you tell by looking at the graph of a function. And some of the graphs are really easy to plot. So you can check them by just plotting them. So if you have a graph like this, you just draw horizontal lines. So horizontal lines mean parallel to x-axis, obviously. This is your x-axis, and you draw lines parallel to x-axis, and you check if those lines, if any of those lines, cut your graph at more than 2 points. So here, this line cuts your graph, even if you have just one. Even if it was like this, even if you have something which is of this
Ma'am?
form, where you have this, and then you
Ma'am,
have this, yes,
ma'am,
yeah.
ma'am, I have a doubt.
Can I just get done with this thing first, and then I can take your doubt? Yeah, so if you have this as graph, and definitely this, firstly, this part is not in your domain, right? You don't have a value for it. So this is, and all the other part of your real line is in the domain. And then if you will draw horizontal lines now, then here it's fine. These lines are fine. They cut the graph only at 1 point. But if you draw a horizontal line here, it cuts the graph at more than 1 point, right? So even if you find one horizontal line which cuts your graph at more than 1 point, it could be 1 point, 2 points, and more than that, then it's not a 1-1 function, right?
Okay, ma'am. Ma'am, can we say that all linear functions are 1-1?
Yeah.
But what about the constant function? Let's say y is equal to a.
We'll come to that. Let me just write this thing first.
Okay.
Yeah. So if we're discussing the linear functions mx plus c type, and they are like this, right?
Ma'am, excuse
Yeah.
me.
Yes.
Ma'am, I have a doubt in the first graph. Just
Yeah.
little
This one.
the parallel, I mean horizontal line cuts in 2 points.
It doesn't actually, because yeah, it does here. Here it'll cut here. Yeah, so this is not 1-1 as well. This is not 1-1. This is also not 1-1. This is not one. They're all graphs that are not 1-1. If you want a graph that's 1-1, you can do it like this. This is a 1-1 graph where no matter how many horizontal lines you draw, you'll always get your graph cut at only 1 point.
Okay, ma'am. The third, please, could you explain again once again the fourth graph?
This one,
Under this one, the under
this one.
last this one.
Okay, this one is here. The domain is this thing. So firstly, this part that I've marked is not in the domain. And then the other part on the real line is in the domain, right? Because we don't have the function defined here. Your function is this. From here to here. Afterwards, it's constant. So after this point, it's constant. And then before it, it's this. So because at this point, if you draw a horizontal line here, you see it cuts at more than 1 point, right?
I can't understand, ma'am. Could you please?
This is your graph. It looks like this. And afterwards, it's constant. Let's just first discuss, even if it was not constant, let's just simplify it, because we'll discuss the constant one here. Again, let's just do this thing. What happens is, here your function is not defined, so this part is not in the domain. And at this point, your function's value is this, which is the same as this one, right? At this point, your function's value is again the same. So it's the same. So if you draw a horizontal line here, it cuts the graph at 2 points, right?
Yeah.
One at this one and the other one at this one.
Hmm.
That's why it's not 1-1.
I got it, ma'am. Thank you.
Now coming to the linear graph. So a linear one looks like this. I'm drawing a very general one. So this is it. This is how your linear one looks like. So if you draw horizontal lines here, anywhere, it'll only cut the graph once. So this is 1, 1. Then coming to the constant one, if you do, now what you do is, if you take m0 here, you will get y is equals to just c. So you need to make sure that your m is not 0 here. If your m is not 0, then this is 1, 1.
Okay, ma'am.
If this is 0, then this is obviously a constant line. All points take the same value, so not 1, 1.
Okay, ma'am.
Okay. Then this is the graphical way of telling if your function is 1, 1 or not. Then second one is obviously the basic, which is your definition. So let's just say you've been given a function. How do you use the definition? Let's say you have been given 3x plus 2, right? And you have to check if this is 1, 1 or not. So we already know from here that it's a 1, 1 function. From here we know this, right? From the graph of it, we can check that this is a 1, 1 function. But if we want to test it using the definition, what we can do is we can take two different points, 3x1. This is fx1 and fx2. Let's just assume that at two different points, your function is same, right? And then we'll show that x1 and x2 are not two different points. They're the same point. That's what your definition says, right? So you equate these two at two different points. And what do you get from here? 2 and 2 gets cancelled. And then you are left with 3x1 equals to 3x2. And then these two gets cancelled. So this is x1 equals x. So I left with this thing, right? So if starting from here, you can conclude that your x1 and x2 are same, then the function is 1, 1, right? This is a 1, 1 function using definition. We'll do more examples where we'll use the definition to prove this thing. Then third way to do it is, if you have, let's just say you've been given a function fx equals to, you've been given fx. And if you can find the roots of this, more than one root, then what does it tell you? Where c is a real number, let's say. And if for some c, which is real, you're able to find more than one root of this equation, then what does it tell you about the one-oneness of this function?
It's not 1, 1.
It's not 1, 1.
Yeah, right. Not 1, 1 because you're able to find 2 points, let's say x1 and x2. Roots means fx1 equals to c and fx2 equals to c. So you're able to find 2 points and your function was fx. So you're able to find 2 points where you get the same value. So either you check, this c could be anything. You can take 0, you can take 1, 2, any real number works here. This is one way to do it. For example, let's just say you've been given x squared plus 1. And then what you do is you equate it to any real number. So let's equate it to, what should be equated to?
5.
Ma'am,
Let's equate it to 2. So you will get from here, you will get x squared equals 1. And here from
Plus
here, you get x
minus
equals to plus minus 1. So you get 2x, x1 is plus 1 and x2 is minus 1, where you get the same value, right? Sometimes what happens is, yeah, this is one way to do it. And the other way is, let's just do an example first because the other way is more about that. Let's say you have something like this, x cube minus plus 7x square plus 3x plus 8. Let's say you have this thing. Then how do you check if this is 1, 1 or not? Because this you can't equate to a constant then find roots, because we don't know how to find the roots of cubic equations.
Put -1 into this equation.
You don't have to use the hit and trial method. That will be too long. What you can do is, you can just remove this part, because let's say if your fx Okay, if your fx plus c is 1, 1, do you think fx is also 1, 1?
Yes,
If
ma'am.
your
Okay.
because
Yes,
Yes,
constant
ma'am.
doesn't
yes,
make a
ma'am.
difference, right?
Yes,
Constant
ma'am.
is not going to make a difference, so you can just remove the constant. So from here, if you want to check if this function is 1, 1, you can just remove 8. You can take x cubed plus 7x squared and 3x. So if this function is 1, 1, then this thing is also going to be 1, 1. Now, one root 1 we already know. If you take x common from here, you can write it as x squared plus
We check
7x.
that it is 1, 1.
What?
How we check that it is 1, 1?
That's what we are doing. We just remove the constant first because constant does not make any difference to the 1, 1-ness of a function. If, or in short, you can say if your fx is 1, 1, then so is your fx plus c, where your c is a constant.
Ma'am, this constant means it is just shifting the graph, right? Okay.
That's why graphically looking at it, you can also examine why it makes sense. This statement makes
And
sense.
it does not affect the m of the line. That means we remove it.
So just not, it's not just about m. We don't know if this what this function is. But when you add something, it just shifts the graph. Even if it's not a linear graph, this adding a constant to a graph just means shifting it. That's all.
It will
That's
not
why
affect
it
the shape
doesn't.
of the graph. It just moves left, right, or up, down.
You can remove this thing, and then you're left with this. So we know that x equals to 0 is one root of this thing. And then what you can do is
Ma'am,
you can
there is
find
one
the
thing.
roots of
Ma'am, there
this.
is one
Yeah.
thing when you remove 8, ma'am. Suppose from x cube plus 7x square plus 3x minus 8 is coming, and there is one root. We can say that it is becoming 0. And can we also say that from other value of x there is also minus 8, and there could be two roots. So eliminating 8 can be a little tricky here because it can give a
No,
0
it's
value
not
on two
tricky. Do
sides.
you think you can solve this thing? Can you find the roots of this?
Ma'am, I was saying from x cube plus 7x square plus 3x, if we get a value minus 8,
Okay.
yeah, so it would be 0. And if from another value of x, we'll get another minus 8. So it will not be 1, 1. So
That's the same thing. Getting minus 8 from here is the same thing
okay,
as
okay.
getting 0 from here.
Okay,
That's
ma'am.
what I'm saying. Can you
Okay,
find
ma'am.
a point for which you'll get minus 8 for this thing? If you can, then you can solve it that way. But I think this one's easier. So one root is x equals to 0, and the other root you can test from here, right? So if you have other roots here, if you can find roots from here, that means at x equals to 0, you'll get the value 0. At some other point, you'll also get 0. So that means you now have, let's say, x equals to a is a root. So at 0 and
And
a,
7,
you get the same value.
7 plus minus 14, 37, around 37 by.
It doesn't matter. We're just doing the way we're just discussing the method. That's all. We're not doing all of it here. So if you have this root, let's say, if you have a real root, x equals to a and x equals to 0, that means at two different points, you get the same value 0, right? That means
Yes,
this
ma'am.
function is, that means this thing is 1, 1. That means this thing is also 1, 1.
If the
Okay.
roots are,
The roots are not
what
real, then
not
Okay,
distinct.
if your roots are not, let's say if your roots are not real, then what you can do is, we know we did this thing, no? Where in the previous one we discussed, we need 2 points where the function's value is same. So you can equate it to C. So at
so
some, it's believable that you might not find roots for this one, but okay, if you're not getting roots for this,
We
if
have
you
to
don't
equal it
find
to
roots
C
for
or
this,
minus
then
C.
ma'am, isn't it better to test in that way f of x1 is equal to f of x2?
And we can find the point near the vertex, which should be which should give you two values, right? Just off the vertex, since it's an x
yeah.
squared term.
And actually, this
That will
thing,
give you two values.
even if you don't find a root here, this thing is a quadratic thing. So it's always going to be like this.
Okay.
This, you obviously are going to get 2 points, x1 and x2. where this thing, this expression in the brackets is going to be same because
Ma'am,
it's a quadratic function, right?
ma'am, if a quadratic function is there which does not have a real roots, can we say that it is a 1-1 function?
A quadratic function is never a 1-1 function. That's the point.
Ma'am, even if does not have a real roots, if it
Yeah,
is
because your quadratic function always looks like this. It's in the parabola form. So you're always going to find 2
Okay.
points where your value is going to be same.
even if
And then the rest is just x.
even if it doesn't have a real root, we can say that
Even if it, yeah,
Means if a
quadratic,
polynomial has at least one turning point, then we can say that it is not 1-1.
Ma'am,
Is
but
that
there is
that's
a
what we
question
did
in
here.
activity. Ma'am, there
Sorry
is
to
an
interrupt, ma'am.
activity.
Could you please repeat how we get this x equals to a?
This is the root.
It
Okay,
just
forget
assume.
about this thing. Forget this. Let's just make it easier. This is a quadratic function. And quadratic functions are never 1-1. So that means you're going to
ma'am.
find x1 and
But
x2 where the
ma'am,
value will be
originally
same.
we are given the cubic equation.
Yes ma'am, and
But
ma'am
we've,
it's tell कि r जो होना चाहिए वो 0 और infinity के बीच में होना चाहिए.
okay, if you
The
have,
domain है.
this is, let me speak, please. If you have this thing, this is a quadratic thing. We've manipulated it into a quadratic one and we've taken the x outside. We've already discussed how we've done this. We've removed the 8, the constant part.
So
And this is why we've removed the
after
constant part.
after manipulating, we get this quadratic equation. There was I get, but on the basis of that manipulation, we say that it is not one-to-one function.
It's not 1-1 because this thing is not 1-1 and you have x in common here, right? So
But
if this thing is
but
not
we
one,
have
let me finish
manipulating
first.
that.
How will you understand if I'll not finish?
Hello.
So you have this thing, x square plus 7x plus 3. This is never going to be 1-1 because it's a quadratic function. We've discussed why quadratic functions cannot be 1-1 because they're always in the shape of a parabola. That's why they can't be 1-1. So this thing is not 1-1. So that means you have x1 and x2, two different points for which this thing gives you the same value. If you'll put x1 here, you get something, and if you'll put x2 here, you'll get that same thing. Now, if you'll multiply with x, these are different, right? X1 and x2 are going to be different then. Yeah, that's going to make a difference.
Ma'am, there is one doubt. If a function is not linear, if it has a degree more than 1, any quadratic equation, any biquadratic equation, it won't be 1-1, na, ma'am. It will never be 1-1, na.
No, it's,
So if any
let's
biquadratic,
just go
quadratic,
for roots only.
yes, ma'am.
If you have x equals to 0 and x equals to a, let's go for roots only because only roots work here. Other points where you get the same value are not going to work for this one. If this is a root of this quadratic part,
Ma'am, suppose we get a quadratic equation in the place of
Can you
this
just
cubic
can you just
equation,
complete
okay,
this point,
if
and we
ma'am?
everyone please
manipulated it
mute
by
yourself. Please mute yourself. We're not discussing that way. That way had a problem and we can't do it that way. This is the new way that I'm trying to discuss here. If you're able to find, because we already know that x equals to 0 is the root of this thing. If you're able to find one more root, you can't find just one root though. You'll either find 2 roots or 0 roots. So if you're able to find one a, which gives one more, so a root of this. If a is the root of this quadratic part, that means at x equals to a, you get 0, and at x equals to 0, you also get 0. That means this function gives you 0 at both points. That means it's not 1-1.
Ma'am, my point is, ma'am, there is one point I have. If there is a equation which has a degree more than 1, that means it is not a linear equation, it's quadratic and biquadratic equation. So by default, it is not 1-1, na, ma'am, no matter what equation is. Just
No, we
asking.
don't know what biquadratics look like.
No, ma'am, quadratic equation, more than 1 degree if it is having, suppose quadratic or cubic. So it is,
Polynomial.
What about x cube? X cube is
ma'am,
1 to
can I
1, right?
complete, ma'am, just once? So can we say that it is not 1-1 function if it is more than
It can be 1-1. More than 1 degree can be 1-1.
like example, ma'am, because there
Please
would
use
be
example.
Someone just gave an example, x cube. X cube is a 1-1 function.
x cube 7.
Ma'am,
Ma'am, but
like
x
any
at x
equation
is
like
equal to
this,
0, there is 0, ma'am. At x is equal to 0, y is 0. So,
We're not
okay,
saying, we're not discussing the zeros, but we did
okay,
it.
ma'am.
This one is some different method.
Okay, ma'am.
ma'am, like
Trying to find 2 points where you can get 0. So instead
My
of
doubt
finding
is
in simple,
if we take
hold on,
if we
please.
take
Let me just
yeah,
complete first. If you have this thing and you can somehow get into this form, there could be degree more than 3. Then we're just trying to find roots of this thing. That's all. We're doing nothing else.
Ma'am, but if we are able to get into this form x common and x square plus 7x plus 3, then though it's not 1, na, ma'am.
Right, this is not 1 because, and for that you'll need two real roots of this. So in case you don't find two real roots of this one, then you can't comment on this.
बट मैम इट्स एज यू हैव सेड कि ग्राफ तो होगा ही मैम वैसे तो एक ना एक अगर अनरियल रूट्स भी आता है तो 1 1 तो होगा ही ना मैम कांट वी से दैट बिकॉज
No, this will be 1 1, but this can make a difference. We have x here as well. That's the problem.
मैम बट द
Originally
quadratic
it is
equation graph would be like that there would be a 2 points so how can it be 1 1 मैम
In this one, you have 2 points. Here you will have 2 points with the same value. Let's say this is x1, this is x2, and you're getting the same value for this. Let's say you're getting a. So the quadratic thing gives you a on both x1 and x2. This will be a, and then you have x2, right? So this will be x1a, x2a. These two can be different. That's the problem. So we can't do it that way.
मैम बट इफ x is 0 then okay we can't say that we cannot comment like that if
Yeah,
x is 0
can't
okay
comment. Okay. Quadratic
I'm
functions, by the way,
asking
are
if
always.
I have a doubt. Yeah, I'm asking that if we have linear equation, then it is not 1 1 or it is 1 1.
We've already
It is
discussed the
1
linear
1.
part here.
It is always
Yeah,
1 1.
we discussed it. We discussed it here. Unless
Ma'am,
you
not
have
So
your
it
even
is
m
all
zero
for
is
means.
linear
0.
equation, it is always 1 1.
Yeah, just make
But
sure that your m is not 0.
okay.
Okay.
so ma'am, the conclusion is like we cannot use this kind of thing, like this kind of analysis for like this analysis is not there for all kind of functions. We need to
Yeah,
see,
nothing is valid for everything. The
but
definition, in
because
fact, the definition is not valid for this one. You can't use the definition to prove this thing.
And
because
ma'am, if
if
we
we
take
consider
x,
all x cubes like functions like that, then everyone will have this x square term. So like we cannot conclude on that basis that it can be 1 1 or not.
Yeah, on this basis, you can't conclude anything. That's what we said at the end.
Yes,
That if you don't get real roots here, you can't conclude anything.
yes.
Similarly, here, if you don't get real roots, you can't conclude anything.
Okay, ma'am. So that like that method is like very difficult to apply because most of the cases like we'll not be able to conclude much.
Yeah.
Okay.
ma'am suppose if there is a quadratic
ma'am,
like cubic equation so if we want to find it if it is a 1 1 or not is the what is the best method is the graphical method best for that or we have to see x1 is equal
You
to x2
can't actually draw the graph of a cubic equation. You can't draw the graph of this manually. You have to use some plotting applications to plot this one.
Ma'am, earlier we used to do that by
The
finding the
plotting,
value of x, something like that, like factors x minus 2 into x minus 3 into x minus 4, like that if we are
that's what
able to
root
factorize it.
means. That's what root means. I've already discussed this thing, no? If you can find a root, if you can find x for this, we've already discussed this method, the root method.
Yes, ma'am. Like if we are able to find the roots and factorize it in the factors form, so we can find the graph. We can make a graph, and through that we can able to find it if it is 1 1 or not.
You can
You can
factorize
do
it
that.
by default, it will not be 1 to 1.
Yeah.
It will not be 1 2.
If you can factorize it, it's
Yeah, because
obviously
you've
not
you've
1 1.
already found two factors, right? Then it
Yeah.
cannot be 1 to 1 because at x it will cut it at 2 points. So it's already not
yes.
1 to 1.
But if
It
it is
will
the roots are not real, then we cannot comment. Yeah.
Okay, coming
Ma'am,
to the
yes,
fourth one.
ma'am.
Yeah.
Can I have this class as a recorded one?
This type of function, there is another way of derivative test, right?
Yeah, it's you can just It's recorded and it's on YouTube. Someone please share the link of the YouTube channel here in the chat box.
Ma'am, just my point was that if
Can I see it in our portal itself?
Sorry, no, it's not on the portal, I guess. You'll have to check YouTube. It's uploaded on YouTube. The fourth point
Okay,
is
ma'am.
if your function is strictly increasing
Yeah, yeah.
or strictly decreasing, then it's not a 1-1 function. Then it's a 1-1 function, sorry. So if you have a strictly increasing function or a strictly decreasing function like this, strictly means, what does strictly increasing mean?
It is
The function
increasing
is
at all
going
the points.
increasing.
Means if
If
your x1 is
x2, yes, ma'am, then f of x1 is less than.
strictly, it's not less than equals to,
Yes, yes. I'm
strictly
sorry.
greater than fx2. That's the difference between strictly increasing and increasing. And same goes for strictly decreasing. So if you have decreasing here, then this one becomes this, and this one becomes this. I'm not writing the whole thing.
so there is no equal to sign, ma'am, in fx1, just more than or greater
Yeah,
than.
this should not be equal to. That's why I've crossed it.
So if it is strictly increasing or decreasing, it's not 1-1, you are saying that.
Yeah,
Then,
it
ma'am,
is
on the
1-1. It
right
is 1-1.
side, it should
If
not
your
be there,
function
na?
is strictly increasing, then it is 1-1, and if it is strictly decreasing, then it is 1-1.
Yeah.
Ma'am, then
And can you
for
repeat for
decreasing functions, it should be less than, right? F of x1, if x1
Yeah,
is
we've
greater
done
than
this.
x2,
We've changed
yeah.
the signs
ma'am,
here in
can you
brackets.
repeat,
There, ma'am, that should be less than on the right hand side.
This one?
Yes, ma'am, for the decreasing
Yeah,
one.
wait. Sorry. This one is just the same.
can you repeat
Actually,
this
this one
method, ma'am?
should be different. This one should be the same. This one's the same, yeah.
Yes.
This is what it is. Okay, so this is it. That means if your function is either this, if it's strictly decreasing or it's strictly decreasing, then it can't be 1-1. It is 1-1, sorry. This is 1-1, right? If it's a strictly increasing function, that's what it looks like. That means at no 2 points you can have same value. Otherwise, this definition will be violated. Is it fine?
Ma'am, what do you mean about
Yes, ma'am.
x2 is greater than x1?
What do you not understand in this part? If this means when you are x1 or x2 in the domain, this is the elements from the domain. If your x1 is less than x2, this is what it means. What's confusing here?
Then what happened, ma'am?
This is what happens. If this happens, then this is the definition of strictly increasing.
Okay, ma'am.
If your function is a strictly increasing or decreasing function, then it's 1-1. This is one thing. For example, your linear equations are one example of it. Then your cubic
Ma'am,
x cube is
strictly means power to 2 or more.
strictly means this thing. This is the definition. If your x1 is less than x2, if your x1 is strictly less than x2, then your fx1 should be strictly less than means not equal to. Like 2 is strictly less than 3 because it can never be equal to 3. Is it fine?
Yes, ma'am.
These are some methods to check if your function is 1-1 or not. And none of them guarantees you anything. So if you have a function, you test if this is an increasing function. If it's a strictly increasing function, it's 1-1. If it's a strictly decreasing function, it's 1-1. But if it's not strictly increasing or decreasing, then you can't comment. Similar is the case here. If you don't find the roots of this thing, then you can't comment. Same is the case here. If you can't find points where your fx is equals to c, then you can't comment. And you always will not be able to plot the graphs of things. just as we saw in this case. In this case, it's very difficult to plot unless you factorize this thing and you're able to and if you're able to factorize it, then you don't need the graph.
Ma'am, if we are able to factorize the cubic equation and we get like x minus 8, x minus 3, x minus 4 into like, then we
Okay.
can, yeah. And if we are able to plot a graph just like on its 1 1.
Don't
You're getting at least 1 1.
You're getting something like this, then you already
ma'am.
have found your answer. You don't need to plot it.
Yes,
That means
ma'am.
at 8, 7, and 2, you get 0. Same value. Now you don't need to plot it.
Ma'am, I have a doubt. If the function is not strictly increasing or decreasing, then it is not 1 1. No, like we can say.
No, you can't
Can
say
you give a
that. If
counter example?
let's take this as counter example, this is a function and then this is it. And the domain does not include this part. There's nothing here.
Oh, based on domain.
So obviously a discontinuous function. But then it's increasing here, decreasing here, and it's not, it is 1 1.
Okay, got it. Thank you.
Okay. Then coming to exponential functions. The exponential functions are the functions of this form, ax, where your a is a constant. For simplicity, let's just take 2 to the power x. And on the other hand, or let's take 5 to the power x and 0.5 to the power x to cover both cases. We'll be making cases here. So this is what it means, where a is your constant and x is the variable. Whenever you have a function in x, you have a variable, right? So this is that variable. This is a constant thing, like this one and this one. So if you look at 5 to the power x, let's just come to this one. We're not doing the 0.1 power, 0.2 power and all of that, because x, you can take anything, right? Let's take 5, then you will take 5 square, so you will get 25. 5 to the power 0 is 1. 5 to the power 1 is 5. Then you will get 25 at 2, and then 125, and then so on, right? And then for 0.5 to the power x, you're going to get 1 first, then 0.5, then 0.25, then 0.125, and so on. That means this is an increasing thing, right? And this
Ma'am,
is a
this A
decreasing
has
thing.
to be non-zero.
A to the power 0,
Yeah,
x 0.
it's non-zero.
If
If
A
A
is
is
zero,
0, then everything is
then
0.
yes, ma'am.
We're just discussing this one, 5 and 0.5. We're not going into the cases right now. I just want you to notice that this, for 5, it's increasing, and for 0.5, it's decreasing. And it keeps decreasing. Now it's 0.125. Next, it will be 0.625. This one keeps decreasing. This one keeps increasing. So what happens is, let's say you have a to the power x. On this basis, we make two cases. By one, you take a greater than 1. And here you take a to the power x, where your a is between 0 and 1. Strictly between 0 and 1. You'll take 0, the whole function will be 0. If you'll take 1, the whole function will be 1. No point taking these 2 points, right? Let's take these things. So if your a is, let's say your a is greater than 1, then first thing we know about this thing, we just discussed it, is a to the power x is increasing, right? Or let's not do that. Let's just start with the very basics. Let's come to the domain first. What do you think is the domain of a to the power x?
Real number.
Ma'am,
0
domain
to
is all real number.
Yeah, all real numbers, because you can put anything here. Then, and before coming to this one, let's discuss the exponentials first. So as to make clear why you can take the domain to be all real numbers. I think that will help. So let's say you have a, s, and a, t. So if you multiply a to the power s and a to the power t, you'll get a to the power s plus t. The next one is a to the power s and t, where t is to the power, it's raised to the power a to the power s. So it's raised to this base. This is AST. Then AB to the power S, which will give you A to the power S, B to the power S. Then A to the power S by A to the power T, which will give you A to the power S minus T. Or before this, you could have written this thing, 1 by A to the power S, which gives you this, A to the power minus S. And then you have A to the power 0 as 1 for all A, except you take A to be 0. You can't take A to be 0 here. And then A to the power M by N. This means A to the power M and nth root of this thing. Nth root, you know what nth root is, right? Nth root of a number is y to the power n is x. Just like the square root, we have nth root. So these are some rules of exponents that you need to remember. So why I did this thing before plotting or before discussing that thing is because you can have negatives here. From here you can see that you can have negative numbers here. From here you can see that you can have irrational numbers here, right? Rational numbers here, m by n form. You can have any other number too. You can
Ma'am,
have irrationals too.
Ma'am, if
Isn't
there is a
it
function, ma'am, if there is a function which is not strictly increasing, it is just increasing. Can we say that it is always not 1, 1?
Always not 1, 1. No, we can't comment about it. If it's given to be difference between, if you say that it's not strictly increasing, that means it's not 1, 1.
Always.
Yeah, because if you're saying it's not strictly increasing means this for strictly increasing. This means that you get 2 points, x1 and x2. When you're sure that this function is not strictly increasing, what you mean is you get x1 and x2 where your function has same values. When you know that it's not strictly increasing, but it's increasing.
It is always not 1, 1. You are saying that.
Yeah.
Ma'am, what is the
If a,
reason you
fu-
are saying? Because
if a function is increasing, but it's not strictly increasing, it essentially means that you get x1 and x2 where your function has same value. Because the only difference between strictly increasing and increasing is this. In one, you get this thing, and in other one, you get this thing. So if you say that this thing is happening, but this thing is not happening, that means you get 2 points x1 and x2, where your function's value is same.
meaning that equal to also came with increasing. So that's
Yeah.
why.
But when you say it's not strictly increasing, make sure that it's mentioned that it's an increasing function first. Not strictly increasing, but increasing functions are not 1, 1.
And we can say that if it is strictly increasing, it is always 1, 1. Like, okay.
Okay. Then we were discussing about a to the power x, where in one case your a is this, in other case your a is in between 0 and 1. We've made two cases, we've covered everything. Why we're not covering the negatives? Can anyone mention the reason why we're not taking a to be negative or 0 or 1? We're avoiding these numbers, right?
If we take the negatives, then our function will fluctuate.
If you'll take negatives, then the simple thing would be if you'll take a -1, say, and or a -2, and then you'll take to the power half. And this is not possible because -2 you can't take square root of it in real numbers. That's why you're not taking negatives here. You're not considering a to be negative because then your range, and for a lot of values, for 2, for half, for 1 by 4, you'll have problem solving this. Not problem, you won't have a real solution to this.
To stay in the real domain, we have
Yeah.
to keep them positive.
Yes. And then 0 you're not taking because each time you'll just get 0 then. And 1 because each time you'll get 1 then. So if you'll take this thing, the first thing about this, we were discussing the domain of it. The domain is real numbers. Then coming to the range, before discussing the range, let's just discuss how the graph of it looks like. So a to the power x graph looks like this. When your a is greater than 1, it's an increasing thing like this. And here, domains again are no change. And the graph looks like this. And then coming now, let's just come to the range. What do you think is the range of this thing?
0 to infinity.
0 to infinity.
Zero not included, I
Yeah,
guess.
0 not included. And this one?
Ma'am, at minus infinity, the value of a to the power x is in 0, no? 0
What?
should be included.
It's not included. You're never
At
attaining
minus
0.
infinity.
Minus infinity is not a point in real numbers. Minus infinity is not a
Ma'am,
number.
I have a doubt here. As you were saying that it will not never attain 0, but
It is
I have
horizontal
seen
asymptote.
graphs
The word is
cutting y-axis in the
asymptotes,
next.
right? For this.
One person at a time, please.
Ma'am, yeah, I was saying that I have seen some examples where this y-axis is cut at minus, like minus 10, 16, etc. So this graph will be drawn at the bottom of the x-axis. So in that case, what happens? It is going to cut x-axis at some point, right?
It's going to cut x-axis, but that's not the graph of this thing. What you're talking about is shifting the things. Then
Okay.
this is not the graph of this thing, it's graph of something else. So if you have shifted it here, you're saying that this is a line here, and it's this thing. That's what you're saying, right?
Yes.
Means you've shifted x, you have not shifted, y you have shifted, right?
Mhm.
The origin gets shifted to this point. If this was 0, 0, initially this gets shifted to this now, which is 0, a, let's say. If this is your line y is equals to a, then this equation will look like y minus a to the power, let's not take a, let's take this to be b. This will be y minus b, a to the power x. This is not the same as a to the power x. This is a to the power x plus b then.
Okay, ma'am.
This is a different graph. Then obviously the range and all of it is going to change.
So this is also an exponential function, right?
This is an exponential function, but it's not of this form, right? We're discussing
Okay.
majorly of these forms. Obviously, if you shift the origins,
But
then the things are going to change.
in the activity questions, there were a few questions which were defining the y as minus 32 or something. So I just saw the graphs of those, and then this question came to my mind.
Yeah, okay. Is it clear now? The
Yes,
range of
ma'am.
this is going to change. The range changes here. It doesn't start from 0 anymore then. It starts from A, obviously, sorry, B. B not attained, and then infinity. This will be the range then.
Okay. Thank you.
Okay. So we're just discussing a to the power x for now. No shifting of things. And the range we have discussed, domain discussed, and then let's talk about the x-intercept then. So what do you think is the x-intercept of this?
Nothing, ma'am.
No, nil. It's nil.
No x-intercept. And here, it's the same. No
No
x-intercept here
intercept.
either. And what about the y-intercept?
1.
1. 1.
This point is 0, 1. So y-intercept is 0, 1. What about the other one?
Same. 1.
Does anyone have a doubt in, if you have a doubt in how we are getting these things, you
Yes
can
मैम
ask.
मैम रेंज मैम मैम राइट साइड में जो मैम जो ग्राफ है उसका रेंज कैसे है मैम 0 to infinity
What is the range? How do you define range?
मैम possible output
Yeah, and how do you
sorry
plot the outputs in a graph?
Do people keep them, do not keep themselves muted? It's very disturbing.
Yeah, please, everyone just keep yourself on mute unless you have a doubt. Yeah, so in this part, how do you what is the range on the graph? If this is a graph, what do you think should be the range? This isn't your y is the output, right? Outputs are plotted on the y-axis. This should be the range, right? Starting from here and going till infinity. This point not included because it's not attained. Starts
Ma'am,
from
in
here,
the
goes till infinity. Yes.
uh, so what I'm saying is, in the left side graph, if we are taking a very small x, then it will just approach to the 0. I mean, it will not, it will never touch the 0. Is that, ma'am?
Yeah. It's never going to touch 0. And
Okay.
here
That's
also it
what
never touches 0.
yes, ma'am. That's what the concept of limit, right, ma'am?
Yeah.
Okay.
Okay, coming to the next point then. Next up you have end behavior. So end behavior means when your x tends to infinity. So when your x tends to infinity, a to the power x, and this is for a greater than 1. Where does your a to the power x go?
Infinity.
It goes to infinity, and we also checked it here in the one example that we did here. You can just check that it increases, it keeps increasing. That means it's going to infinity. No matter what you take here, if it's a number greater than 1, it's going to infinity. And if it's a number greater than 1, less than 1, then this is going to 0, right? It's constantly decreasing. 1, then 0.5, then 0.25, 0.125, then 0.625, and then it keeps increasing and approaches to 0. And you can just check it from here too, that it keeps decreasing. As your x increases, this is x tends to infinity. This is minus infinity. So when x tends to plus infinity, your function tends to 0. Function's values are here on y-axis. And when x tends to minus infinity, what happens then?
0
X tends to 0.
0, right? And here,
0. Ax tends to 0 and minus infinity. A tends to infinity. Ma'am, the right side graph, the equation is a minus x, a to the power minus x. Is it this right one?
so it's just a to the power x, but your a here is between 0 and 1.
Okay. Okay.
This is all about exponential curves. And then there is a special type of exponential curve, which is e to the power x. Here e is an irrational number, which is 2.71, and because it never stops, so it keeps going on. It's this thing. And how do we use it? We generally use it for compounding things. E is used for compound interests and other compounding questions. So let's say initially your value was p. This is the initial value. And then if you want to check that after, let's say, p years, and the compounding is done n times. So compounding done n times per year means this is compounding per year. Compounding per year means if you have compounded monthly, that means, so there are 12 months, and if the if it gets compounded every month, then that means it gets compounded 12 times, right? 12 times in a year, where n will be 12 then. For monthly, it's 12. For quarterly, it's
4.
4.
4.
Ma'am, can you write a
And
equation kind of a form so that we can understand like n is
let
nt?
me just write this thing first. For half yearly, your n is 2. Okay. So these are the things. And then your equation is 1 plus r by, so if you're taking the rate as this thing, 2 by 100
Ma'am,
and 100 of 100, then you don't need to include 100. Otherwise, you should write 100 here. And this is NT. So this is after T years.
Ma'am, sorry to say wrong. Quarterly should 3. Quarterly is 3.
Quarterly is okay.
ma'am, quarterly would be
Quarter
4
is
only, na ma'am?
1/4, right?
Yeah, ma'am. So
Quarter
it would
is
be 4
1/4.
only.
It should be 4. This one's right. So does anyone have a confusion in this formula? You must be very familiar with this formula.
Ma'am,
This
what is
is
the
the
importance of E
What
here?
is n, ma'am? What
Ma'am,
is n, ma'am?
ma'am, what is the importance of E here? Like you said, E is used in compounding. So are we saying that n like 1 plus r upon
this
n?
is the limit of what happens is it has something to do with the limit of this. When your n tends to, that's where E comes into the picture.
What, ma'am?
When you take the limits here, that's when E comes into picture. You'll have to take n tending to when you take limits, that's when E comes into picture. Not right now. There's no point of it here.
Yeah.
Okay, then you might see some questions on this one as well in your activities and all. So if there's no doubt in this formula, then we can move on to the composition of functions.
Ma'am, what is n, ma'am?
N is the number of times you've done compounding in 1 year. So if you say that that's why I've written this thing here. If your compounding is done monthly, that means your N is 12. Every month, if your initial amount gets compounded, that means your N is 12. If it gets
And r
compounded
is
quarterly, R is the rate at which things are changing.
okay.
Ma'am, you didn't took the horizontal asymptote topic, so that can you take it at last?
Yeah, the horizontal asymptote you can take here. Okay, let's do that too here then. Then you have asymptotes. Asymptotes, what happens is, it's basically this thing. So one very popular example is what we were discussing initially, this thing. This is also an example of asymptote. So when your x tends to infinity, minus infinity, your y tends to 0, right? So your y is equals to 0 in this case is a horizontal asymptote. Or in this case, in the other one, you have this, right? So when your x tends to infinity, this time your y tends to 0. So this is also a horizontal asymptote. Y is equals to 0 again is a horizontal asymptote. Horizontal asymptotes are basically horizontal lines that you keep approaching but you never reach them. So each time your x increases, in this case your x increases, this graph gets closer to this x-axis or y equals to 0 line, but it never touches it. So if this one is like this, then your horizontal, let's say this point is 0 comma a. Then what's the horizontal asymptote here?
A.
Yeah, y
Y
equals to
equal
a.
to A.
Because when your x tends to infinity, your y tends to a. That means your y equals to a is a horizontal asymptote in this case. So these are horizontal asymptotes. Similarly, we also discuss vertical ones. Let's just say you have y is equals to 1 by x for x greater than 0. And this one looks like this, right? So in this case, when your y tends to,
And there is
okay,
one more graph in the third quarter.
what?
Ma'am, can we say that on asymptote, like if there is a function and asymptote is happening, can we say that the function is 1, 1, 1?
You see, the
Like,
asymptotes are not always this. They can be like this thing, and then they go like this.
okay,
So you can't say anything
no,
about
no, ma'am,
asymptotes.
just the asymptote area, if you want to say, and if you want to limit the value of x from the asymptote area, can we say that the asymptote area is 1, 1? Like e to the power x that we were doing, there is an
That's not
asymptote
how
there.
asymptotes happen. What happens is, I don't want to get into that part because even if you have, let's say you say that at some points you have
Like,
this thing and then it decreases, and at some point, after some point, it goes this and then it decreases
no,
again.
ma'am, my point
You
is like
can't
e to
just
the
say this.
power x. When there is e to the power x, there is an asymptote happening. So we can say that it is 1, 1, 1, 1 function, na, ma'am, because there is a straight asymptote
To the
happening in e
power
to.
x is That's not the reason e to the power x is 1, 1. That's what I'm explaining. The reason e to the power x is 1, 1 is different because you can say a lot of things because it's strictly increasing function
Yes, ma'am,
or
that
for
is
other.
fine. But graphically, if you want to comment on that through asymptote, can we say that it is a 1, 1 function? Only through asymptote, graphically.
You Okay, your e to the power x looks like this thing.
Yeah, ma'am.
Now,
There is an
graphically, if you
asymptote.
want to conclude, then the
Yeah,
reason is these horizontal lines are the reason
yeah, ma'am.
because they
But
cut only at one point.
even at asymptote, we can.
Asymptote has nothing to do with it.
Okay. Even if it is having an asymptote, that means it is 1, 1 only. That is my doubt. Graphically commenting on that.
Asymptotes do not imply that your function is 1, 1. In simple words, having asymptotes doesn't guarantee anything. Okay. So if you have this thing in vertical asymptotes, what happens is when your x tends to, in this case, when your x tends to 0, your y tends, when your y tends to 0, your x tends to infinity, right? This is a vertical asymptote. Vertical asymptotes are basically, so previously we used to have y equals to something, this time you'll have x equals to 0. So this is your vertical asymptote in this case. X equals to 0 is a vertical asymptote here. This is x equals to 0 line. This thing, your y-axis is x equals to 0. So this is a vertical asymptote.
You
This is
wrote
a
no.
horizontal asymptote.
No, you draw only half a part of a 1 by x graph. There is
Yeah,
another part.
because I don't want to take this one.
I have a
I just
doubt in
wanted
it. Ma'am, if we draw the other half of a graph, then how
Yeah.
can we say what is asymptote? Because there are two different line going to each other differently bi-directional दिशा में एक दूसरे ऊपर जा रहा है एक नीचे आ रहा.
That's fine. These are still, y equals to 0 is still an asymptote. That's fine. Because when your y tends to 0, x tends to infinity here, and then other one it tends to minus infinity. Which still
Actually, x is equal to 0 is asymptote, ma'am.
consider this thing. Let's not get
Okay,
into the
ma'am.
limits part.
Okay, ma'am.
That's why I'm avoiding it. Take this thing.
Ma'am, for this graph, x equal to 0 is asymptote, no, ma'am.
Let's consider this one for simplicity. X equals to 0 is an asymptote, and x equals to 0 is a vertical asymptote. Y equals to 0 is also an asymptote here. But that's a horizontal asymptote.
Okay.
Is the asymptote part clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Ma'am, is
clear.
there any practical application of this in the questions? Because graphically it is clear, ma'am, but
Practical application as such, you just need to know the limits a simple idea of limits. When this tends to 0, where does this thing tend?
It is
That's
uses
all you
basically
will be asked. That all you will be using. That's all you will be using. That's all. Then let's come. Can we move on to composite functions now?
Yes, ma'am.
Okay. So in composite functions are basically what, so if this is your fx, we know that this is the input thing, right? X is your input and fx is output. So if output of one function, you make input of some other function, let's just say you apply a g here. So what you're doing here is you have an x and then you apply f to it, apply one function to it. Now this is output of f, right? And to output of f, apply g. So your output of f now becomes input of g, right? This is called x in this fx. This is called argument. So this is x is argument of f, and what's the argument of g then?
F of x.
fx.
Right. This is your argument. This is the argument of g. Right. So what you're doing is first to x you're applying f, so you're getting fx, and then to this thing you're applying g function. So you're getting g fx. Let's do one example on this. Let's say you have f equals to x plus, not writing x here, and then g equals to x square. Let's take this example. Then what do you think is f o g? Let's just do it step by step. So g, first you apply g to x, so you get x square. Then you apply f to it. Now in place of x, here your fx is x plus 2. So your fx square should be, what should be your fx square then?
X square plus
X
2.
square plus 2.
Right. Just replace x with x square. That's it. Because now your argument is x square. This thing is x square plus 2. What happens is, we'll come to this. Domain you'll have to specify. The domain, we need domain specification. We'll do it later. And then let's do GOF. What is GOF?
X plus
X plus
2.
2 whole square.
The whole square. Yes.
Yeah. First you do x plus 2. And then you apply G on it. So you get, our argument is, here your argument is x. And now you would have to take x plus 2. So instead of x, take x plus 2 whole square. Now coming to the domain of the composition. Let's say you have D we're using for domain. What's the domain of FOG? So write this thing, okay. This thing, FOG or GOF that we've written is just this thing. F applied to GX. I hope this is clear to everyone. This is just a notational thing. So what's the domain of FOG? First, what you do is, let's just find, domain is basically what you can put in here, right? For which this whole thing is defined. So firstly, you will need G to be defined on X. So you need X such that your G is defined on it, right? And what do we call the collection of all the X where your G is defined?
That is called the domain of G.
Yeah, it's domain of G. If anyone has a doubt in how we're doing things, you can just unmute yourself and ask. And then I hope everyone's familiar with what an intersection is.
Yes, ma'am.
Intersection means you need to satisfy this condition, and whatever we'll write here, you also need to satisfy this. If I say A intersection B, it's basically A, it's in A and it's in B as well. And is the main point here. So first you need to check that you can apply G to it, right?
Ma'am, we can say
only
that
correct.
the intersection is a kind of an AND gate and union is a kind of an OR gate, kind
Yeah.
of.
But where we only need intersection here. When I'll write this thing and the other set, this is a set, right? Domain of G is a set. So one set is this and other set I'll write here. That would mean that the x you'll get is in this set and it's in the other set too. So your domain of this thing is, first you need to know that you need to make sure that you can apply x g to your x. And then you need to make sure that you can apply f to your gx, right? But do we need to do it for all gx?
Ma'am,
Yes, ma'am.
ma'am, what is the question?
Okay, let's just do this first. This is your FOG x, right? So first you just need to make sure if your x belongs to domain of FOG, that means firstly your x should be something that you can apply g to.
Yes, ma'am.
First thing is this. So it should be in the domain of G. The next thing is your X, you need to make sure that your GX is in the domain of F, right?
Means the range of GX.
Range of G should be in domain of F.
Okay, ma'am.
X is coming from real numbers.
Okay, ma'am.
What we've done here is first we've applied G to make sure that you can apply G to X in the domain of this thing. First, what you do is you need to make sure that you can apply G to it. That means X, which on which you can apply G. So that's domain of G. And then X such that you can apply F on
Ma'am,
GX.
some noise
That's what
is
we've done
coming
here.
in.
That's not
Some,
from my side. Whose mic is?
yeah, from someone else, please mute.
Okay. And then the next one is this. So first you make sure that you can apply G to X. So it's the collection of all the X such that you can apply G to those X, and then those X such that GX is in the domain of F. Is this part clear to everyone?
Yes, ma'am.
Ma'am, what is the
Yes, ma'am.
conclusion? Means
This
fine.
is the conclusion.
Ma'am, it is clear.
This is the formula.
Like we need some examples.
Yeah. We'll do examples, but first, because I'll be using this in examples.
Okay, ma'am.
Please, briefly, can you repeat?
Sure. So you need to find domain of FGX, right?
Oh, ma'am,
Domain of
in
FGX.
previous slide, ma'am. Start from previous slide, ma'am. X plus 2 जहाँ पे एग्जांपल लिया था, टेक एग्जांपल है F plus 2 and yes ma'am, उसमें yes ma'am.
We'll do example on it. If okay, let's just do an example only then. We took an example where we had fx equals to x plus 2 and gx we had as x square. So if you'll compose them, if you'll take FOG, you'll have x square plus 2, right? This one's very simple because if you look at the domain of it, so first what you do is first you need to make sure. That's why I wanted you to understand the formula first because I'll apply it here now. So what's the domain of G here? First you need the domain of G, right? What's the domain of G?
Real numbers are.
One second, ma'am.
And then the other set was collection of x belonging to R such that your gx is in domain of F. So for that, first you need to find domain of F. What's the domain of F? It's also R, right?
Yes, ma'am.
So if I need to know collection of x, I need to know the points x where your gx is in R, right? We can replace this domain of F by R. Yeah, because it's R. So we need x in real numbers such that your gx is in real numbers. So isn't it true for all x belonging to real numbers? Because if you have a number x, then gx is always going to be in real numbers, right? If gx is defined for it.
Yes, ma'am.
Yes, ma'am.
That means this thing is going to be real numbers only, right? This set is real, this whole set, let's call it A. But A set is real numbers only, right?
Yes, ma'am.
So your DG, this intersection, this thing should be R intersection R. It's a very easy example. So it's going to be R only. Just give me a second.
Then we can take g of x as let's say x square and f of x as 1 by root under x or 1 by root under x plus 2, that kind of
Yes,
thing.
ma'am. This type of question.
Ma'am, here what are you trying to
what?
do?
Ma'am, let's say g of x is
Was a
x.
very easy example. I'll take a trickier one. Let me just take another example. Or
Ma'am,
does
we
someone
take the
else want to suggest some
intersection.
other example?
Like I don't understand why intersection.
Okay. When you have FOGX, let's say, I said that the domain of this entire thing is domain of G intersection with X. Intersection just means,
The common elements.
yeah, common elements, or you can say some element that belongs to this and that element belongs to this set as well. So if this confuses you, what you can do is, let's just do this only. This is DG, and then you have X belonging to real numbers. Instead, what I was suggesting is instead of this real number, you can put DG here so that you don't have to take intersection. This should be, your GX should be in domain of F. This was the definition, right? So first you
Yes.
make sure, what is this set? This is collection of X such that X is in domain of G and X is in real numbers such that, or X is a real number. We can say, and X is a real number. And Gx is in domain of F, right? So if X belongs to this set, then this is what it means, right? It satisfies these three conditions. So first you take,
Ma'am,
yes,
so ma'am, an example could be g of x is equal to root under of x and f of x is equal to 1 by x. If
let's
we
not go to
find...
the example. Let's just get this definition clear first. How do you do this thing?
Okay, okay, ma'am.
Because someone has a doubt in this thing. So X is in domain of this condition you get from here. So if you want your X to be in domain of FOG, this is equivalent to saying that your X is in domain of G, your X is in R, and your GX is in domain of F. So you need X to be in domain of FGX. This is the condition that you need, right? So how do you get this? First, you need to make sure that you can apply G to it. That means X is in domain of G, and then you need to make sure that you can apply F to GX. That means your Fx is in domain of F, your GX is in domain of F. They've just written this entire thing in a set form. That's all.
Okay.
Now let's do an example on this one. So is someone suggesting some example or can I take on my own?
We can
Then take on your own.
When we can take a function example fx of under root and gx can be
F of,
Yeah, we'll
yes,
take
ma'am.
under root, but let's just take square first. Because squares are also, let's say you have x square and you have gx equals to root x. We know that you'll have to mention here that your x is greater than 0. Even if it's not given, it's obvious that your x is greater than equals to 0, right?
Yes, ma'am.
Okay. So if you'll do GOF here, and let's take, okay, we'll do that case later. This is it, right? Or let's just do this first because it will be easier to understand for you. Because this was x greater than 0, so we also have put a condition here on the domain of this function. So the domain of this function is starting from 0 going till infinity. The domain of this function is also the same, starting from 0 and going till infinity. So your domain of GOF, your GOF is, it looks like this, your square root this, and then x, right? What's domain
Yes.
of GOF?
X.
What is the
X.
domain of G of X?
That
It's
would
R,
be,
right?
It should be
ma'am,
Or it should be
domain
greater
of,
than 0 because R is,
greater than 0, ma'am. Plus R.
yeah, because
yes,
R is
ma'am.
not here. Domain
Strictly
should
greater
be,
than 0, right?
yeah, it's this. Not strictly greater. Why strictly greater? You can take 0.
Ma'am, because the domain of g of x is okay. Yeah, ma'am, got it.
And then similarly, you can do for FOGX. So where FOGX is
X.
square root of x square, and this will be x. So again, the domain is going to be, so what's the domain here? It's again the same, 0 to infinity, right?
Yes, ma'am. Ma'am, can you take another example?
OG.
And the previous one, ma'am, X plus 2.
Ma'am, let me
Okay, we
let
can
me
take another example, but before that, I want you to take this one first. Let's take x square for x belonging to real numbers. This time we're taking real numbers and gx as root x. Where obviously you can't take x from real numbers. This should be the domain then. So if you'll do GOF this time, what is it going to be?
X.
Root under of x square.
And what is it?
X only.
X.
Mod x.
Oh.
So
Okay.
when you take whole real number, so for example, let's say you put x equals to
And
2
then
here.
previous one, वो पहले वाले में भी mod होगा ना?
No, उसमें नहीं होगा.
पहले का.
So mod there. You have 2 square here, and then you take the square root. 2 square is 4, and then the square root is 2. This is fine. You could have taken x for this. That means this suggests it's a square, this thing is x, right?
Ma'am, why there is mod on x? Because x square.
That's what I'm explaining. That is what I'm explaining, if you let me. And this is a request to all of you. If I'm explaining something, don't interrupt in between. Because almost all the time, that's what I'm going to explain. The question that you're asking is what I'm going to explain next. So this is, but if you'll take minus 2 square, then this is 2, right?
2.
So that means you took something negative. X was negative. X is minus 2. But the result that you got is x is minus 2. But the result that you got is 2. That means you got minus of minus 2. That's why you take a mod here.
Yes, ma'am. Always get positive.
That
Ma'am,
means
but if we are able to find the domain of GOF, what would be the domain? It would be all real numbers, na?
that's all real numbers. Domain is all real
Ma'am, but
numbers.
yeah, ma'am, but on the last slide when you were doing it on the previous slide.
Previous question was different.
No, ma'am, just here on
It
the
has
left.
this here.
Yeah, ma'am. Here also the domain should be all real numbers, na? Because on X it can be anything. Why
Which
0 to
one?
infinity here?
This
The
one or
left
this
one,
one?
ma'am. The left one, ma'am.
Left one, the domain of f is greater than 0. How can you take? Just look at this definition.
Yeah, so because of the intersection thing, we took 0 to
Yes.
infinity, because here the value of x can be under root of x ka whole square. The x can be, ma'am, like all real numbers, because even the negative number is
Can
getting
be
square
all
here.
real numbers, but you can't take all real numbers here, right?
Why not, ma'am?
When you
Because it
have
is getting
fx,
square.
let's say you have x square. Your x is, you have already mentioned in the question that your domain of f is greater
So
than 0.
defining the domain as greater
Then
than
how can
0
you put
already.
0 here? How can you put a negative number
Ma'am,
here
but
when you know?
if in the question it's not there, na, then we can say that, na.
But I've already written it there. That's why I'm making two cases. That's why I've done this question separately from this one. And that's why the domain changes here. In fact, the function itself changes here.
Okay, because you restricted the domain in the previous one.
Is actually, this is also mod x only. But since you're only taking positive values of x, that means you can write it as x only. Is it fine?
Yes.
Yes.
Ma'am, can you,
Yes,
ma'am, can you domain, ma'am, can you repeat domain, ma'am? How is it
Domain
domain,
of
ma'am?
what?
Example first, ma'am. Zero of f.
This one or the
Domain,
previous one?
yes, 0 to infinity, how we get it? Because x is greater than 0, so lower limit is 0, and we tend to infinity, that's why go
This
to
domain is equal to domain of f. What is the domain of f here?
0 to infinity. R real number. Okay, ma'am.
What is it? Is it fine?
Okay.
Should I do it?
Okay. Yes, ma'am.
Okay. So is this part clear why we are taking mod x here? We also take mod x here, but it eventually becomes x only because here x is always good. We've taken x to be greater than or equal to 0. That's why you don't have to take mod x. It's understood that mod x and x are same for x greater than 0. That's why we are not writing mod x. But here you need to mention mod x because your x comes from real numbers. Okay, then we can move on to some other example.
Ma'am, the domain of f of g. Second question, this question. F of g, it should be greater than 0, 0 to infinity.
For FOG,
Yes, ma'am.
so FOG will be,
Because
yeah,
we
it's greater
can.
than 0. It's this
Yes,
thing.
ma'am.
Domain of this is this. First you take the domain of G. Domain of G is x greater
0
than
to
0. So 0, yeah, this thing is the domain of G. And then you take x from real numbers and that your gx. For that
दोनों
you
का intersection.
gx is always great. Do you want, does anyone want me to explain this thing? In this example, your domain of G is 0 to infinity. Then your x, the other set where your gx belongs to domain of f. For that, you need to find the domain of f. So the domain of f is real numbers in this particular example. So instead of writing domain of f, we're writing just real numbers here. The x belonging to real numbers such that gx is in real numbers. This set is real numbers, set of real numbers only. And if you'll take the intersection of both of these, you'll get 0 to infinity. That's how you get this thing.
Ma'am, just one
Can we
doubt.
move on?
Ma'am,
Yeah.
just last in that, what was the necessity of writing mod x? Because x can be anything.
just
Because, ma'am, the domain on the right side, you have written the domain of g of x r. That is all real number.
The
That
necessity is if you're writing GOF, then it should be this only. You can't write it as x. I wanted you people to know that when these two functions are composed, you don't get x, you get mod x.
but x is anyhow, it will be there will be a square. It would be positive only. So we can write it just as a
No, it's
real.
not going. That's what I've explained here. You take 2 here, the square and square root will give you 2. That means 2 squared. Your x you have taken 2. And the result that you get, g of fx, you get 2. But here if you take x equals to minus 2, the g of fx you get is 2. That means mod, what does mod do? If you have 2 here, it will give you 2. If you have minus 2 here, it will give you plus 2. That's what this function is doing, right?
So that mod x is the range, or you are saying it is a domain? Mod x is range, na?
Mod x is a function. If you want to compose these two functions, this is the resulting function.
The resulting function is mod x. You are saying that
Yeah.
from that. So it is a kind of a range of this GOF. That's what I was saying.
Range and functions are two different things. This is just a function. This is the range.
It's another function. Mod x is another function, which is represented by g of f.
Okay, okay.
Ma'am,
Can
can
we
you
move
take
on to the
a,
example?
ma'am, I have
Yeah.
one doubt, one example. Let us
Yeah.
suppose fx equals to 1 upon x plus 3 and gx equals to 1 upon x.
And your FOG will be equal to 1. And instead of x, you write 1 by x. This will be 1 by x plus 3, right? What do you want me to do? Do you want me to write the function, or do you want me to write... Whenever
No,
you're
ma'am.
writing a composition of function, you need to mention the domain too. That's when your function becomes complete. Function with a domain. So you'll have to mention what all values of x can you not take here. We'll come to that. Let's just solve this thing. It will be 3x
X
plus 1
3 plus
and
x.
x here. So from here, what it looks like is, if you do not know that your f was this, x was this. From here, it looks like you should not be taking x equals to minus 1 by 3, which is true. So in the domain, minus 1 by 3 should not be there. But that's not all. You also need to make sure that your 0 is also not in the domain, right? Because first you apply g, then you apply f.
3 also. Minus 3 from f of
Minus
x.
3, no, you don't need to remove minus 3 from here. Minus 3 can be in the domain. In the domain of this thing, minus 3 can be there.
Okay, ma'am. Now clear. We have to take a intersection of domain of g of x and x,
Yeah.
the possible value of x.
If you look at it this way, the domain of g is r minus 0, right? And the other set that we took, x belonging to r, such that your gx is in domain of f. What is the domain of f? R minus 3.
Yes, ma'am.
So if you'll take gx, gx is this thing, right? 1 by x.
R
So you
minus
need to
0.
make sure, when do you get 3 here? You need to remove that point for which you get 3.
1 upon
1 by
3.
3. 1 by 3.
It's 1 by 3, so you should be removing 1 by 3 as well.
Okay, ma'am.
That's why I was suggesting you to use this formula, because directly looking at things, you might miss some points.
Ma'am, what is the domain of this?
It should be R minus this set.
Okay. And definition wise, this 0 and 1 by 3 should not be there, right?
Yeah, 0, 1 by 3 and also minus 1 by 3 because of this.
So we
Wait.
have to also consider
Have we
that.
made mistake? Wait. Domain of G is this thing. And the other set is X in R, so that Gx is in R minus 3. It's R minus 3, right? Yeah. It's R minus, that's what we've done wrong here. That's why I was thinking there's a mistake somewhere. So it's not R minus 3, this is also a sign of excluding the set. This is this, right? So here you have minus 3. Here you'll get minus 1 by 3. So it's the same set. 0 and minus 1 by 3. You should exclude from R.
Maybe you
So,
written 3, ma'am.
Where?
Ma'am, this half dash is a sign of subtraction also, na ma'am?
Yeah, this is also subtraction.
A
This
set
means
difference.
you've removed A. Yeah, this is set difference. This is also set difference.
A minus 3 or 1 by 3 minus.
Minus 3 you remove from R. So what happens here is you want X in real numbers such that your Gx should not be equal to minus 3. Your Gx is 1 by X. That means 1 by X should not be X such that 1 by X should not be equal to minus 3. This means X such that X should not be equal to 1 by minus 1 by 3. That's why we're removing minus 1 by 3 from here.
Okay, so ma'am, this means that g of x should not be there in the domain of f of x, right?
Yeah.
Okay.
If you will write
Thank you,
this
ma'am.
function, you will write it as x 3x plus 1. But don't forget to mention that this function does not include these 2 points. These 2 points should not be in the domain. That's when your function becomes complete. because this function is different from this function. These two functions are different. And the composition of the two functions that you suggested is this one, not this one, right?
Yes, ma'am.
Yes,
It
ma'am.
is upper one.
Ma'am, just
This one is a different function.
Ma'am, is it a different function only when you restrict the domain?
When you change the domain, the functions become different.
That is the reason.
Yeah. That's why this function is not the same as this one.
Because you restricted the
domains,
domain, you included 0 here.
Yeah. Here we have excluded 0, here we have included it.
Because that was the FOG formed by fx and gx. That's why the range become that's why the domain become different. There is an extra 0. So that's why these two functions are different. You're saying that.
Simple words I'm saying, if you have a function and its domain is D, and if you have, let's say you have x square and its domain is D, and then you take x square on domain D dash, then these two functions are different. That's all. If the domains are different, then the functions are also different. They're considered to be different functions. But that's not of importance here. Okay. Can we move on to the next example now?
Yes,
Yes, ma'am.
Please.
Okay. So let's take this one then. Domain of square root of 2x plus 6. Let's take this one. So can you find two functions of which this function is a composition? This is obviously a composition function. And this is composition of two functions. What's f here and what's g here?
Ma'am, f is root x and g is 2x plus 6. Yeah.
This is it. And obviously you'll have to take x greater than 0. No restrictions here. But here you'll have to take this. So what's the domain of? So because this thing is FOG, right?
Yes, ma'am. This has
So
to
first
be
you should
equals.
take domain of G. Domain of G is R. Then you should take x belonging to real numbers such that your gx is in domain of f. So your domain of f is
0 to
the domain
infinity.
of f.
That
0 to
is,
infinity.
ma'am, is it 0 to infinity? Domain of, okay.
Domain of
This is
f.
f.
Yes.
X cannot be negative, so 0 to infinity.
X cannot. The negative numbers will be excluded.
So if you look at this gx,
Minus 3 to infinity.
what you want is, what is gx? You can write this set as x belonging to R. 2x plus 6 should belong to 0 to infinity, right?
Yes, ma'am. This has to be greater than equal to 0.
This implies that your x should be, so we're considering x belonging to R such that your x is greater than 2x plus 6. 2x plus 6 is greater than 0, greater than equals to 0. So just solve for, if 2x plus 6 is greater than equals to 0, what should be R? Where R should be greater than equals to minus 6 by 2, right?
Yes, minus 3.
That means your x should be greater than equals to minus 3. So this set is minus 3 to infinity.
Yes, ma'am.
This set is minus 3 to infinity. The domain of G was R. If you take the intersection, you're going to get minus 3 to infinity, right?
0 to infinity.
So the domain of composition should be this. Okay, let's complicate it further. And instead of it, let's just take this thing. This time, let's take this thing. I've taken this, but you can be given a quadratic function. It's obviously a quadratic function, something like this. And then you can factorize it, right? Make it look like this. I've taken the factorized form directly. but you can be given the expanded form. And do this first, factorize this first, and then try to find the domain. So what do we need here? So the two functions here again are f. Your f is again root x, and your g is, so if this is your FOG, your f is root x and your g is x minus 1 and x minus 2. So obviously your domain of g is R, we're not doing that part. And then you need x such that your gx is in domain of f. Domain of f is again 0 to infinity, right? So your x from here, we're not doing those steps that we did previously. So from here you will get x belonging to real numbers such that your x minus 1, x minus 2 is greater than 0, greater than equals to 0, right?
Yes, ma'am.
Ma'am, excuse me, I am having one confusion. Means regarding the composite functions actually.
What is it?
Yes, ma'am. How you conclude that कि x root x होगा और x minus 6 होगा, ma'am? Previous question.
This
Previous.
finding these things.
No.
This function is FOG. What do
इसके
you think
पहले
are the
वाले
two
एग्जाम्पल
functions here?
मैम, इसके पहले वाले
Here,
एग्जाम्पल यस, या ये कंपोजिट फंक्शन में आपने fx और gx कैसे निकाला?
Yeah, ma'am. Exactly, I was asking that question.
if you have square root of 2x plus 6.
Ma'am, actually, I wanted to ask that
Yeah.
in finding function of the f of g of x, in one step we actually remove all those x which belongs to domain of g, for which g of x does not belong to domain of f. Am I right or wrong?
Yeah, you do remove x for which your gx is not in the domain from the domain of g.
So exactly what does that mean? Means I have known about this fact, but I cannot understand that part. Sure.
Do you understand how you get the formula dg intersection domain of g intersection this thing? Are you clear how do you get this formula?
One second. X minus. No, ma'am.
We discussed it twice in the beginning. Were you not in the class?
Um,
Then you need to
exactly
find
the.
this. This means selection of x such that you can apply g to it. That means domain of g. Right?
What
Does domain of
once
FOG mean?
domain of f of gx? It
Yeah.
means
What
I
is it?
think domain of g of x.
Yeah, okay, domain of
You've
g
told.
of x.
You have told
And
now.
one condition is this.
Yes.
If I say that your x belongs to domain of FOG, then the first condition is
Okay, ma'am. Okay, ma'am. समझ गया ma'am.
x should belong to domain of g. That you yourself said, right? It should
Yes.
belong to domain of g. And then
Yes.
the second condition, so if you're doing this thing, shouldn't gx also belong to domain of f?
Gx also should belong to domain of f.
Right?
Yeah, ma'am.
You would need x for which gx belongs to domain of f. Right? So for x to be in domain of FOG, first x should be in the domain of G, and second, x should be a real number for which your gx is in domain of f. And then you combine these two conditions. First condition is x should be in domain of G. This,
Yeah.
and second is this represents and, right?
Yes, and yeah.
X should be in real numbers, and it
Such
should be
that
such a number. Yeah. This
gx
thing.
belong to d of f.
That's it.
Yeah.
This should be the domain of FOG. That's it.
Okay, ma'am.
Is it fine now? Okay.
Yeah, ma'am. Thank you.
Coming back to our previous question, we're
Ma'am,
coming to
previous
that.
question. Wait, ma'am. मैम प्रीवियस क्वेश्चन में जो रेंज निकाला वो मैम -3 टू इन्फिनिटी थी और एक 0 to इन्फिनिटी था।
तो हम जो
तो
इंटरसेक्शन है
मैम
वो तो 0 to इन्फिनिटी होना चाहिए ना मैम, आई वाज सेइंग दैट।
यस मैम रेंज, क्योंकि आप 0
Domain of
क्योंकि
G is not 0 to infinity, it's R.
अच्छा
It is not range, it is domain.
It is real number. It's not
Yeah, the
range.
domain of G is real numbers.
Real numbers.
That's fine now. I've taken the intersection of this with real numbers, which will give you this only.
Ma'am, in the previous question we found the intersection of -3 to infinity and
Which one? This one or
yeah
this
ma'am,
one
this
you're talking
one,
about, right?
this one, yeah.
-3 to infinity and R, domain of G.
Okay, okay.
This is -3 to infinity intersected with R. Okay, coming to this one, if you want to make sure, so you need x belonging to real numbers such that this expression is greater than 0, right? So how can you do it? You know you have two linear factors. So the only possible ways are either your x minus 1 and x minus 2, both are greater than equals to 0, right? So if you have two numbers a, b, and I say that this should be greater than 0, then that means the two cases are either a and b both are greater than 0, or your a and b both should be less than 0, right? Is this part fine?
Yes.
Yeah, yeah.
Yes,
We're
ma'am.
going to use it here, b. The same case we're doing here. So if you want this thing, this expression to be greater than 0, and because these are linear ones, so what you can do is you can take these two to be greater than 0. So one case is you find x such that your x minus 1 and x minus 2 both are greater than 0. And the other case is you find x such that your x minus 1 and x minus 2 both are less than 0.
Ma'am, to find its domain, can't we just do from the way we were doing the last time, plotting the graph and making it like minus infinity
Yeah,
to 1? Just we
we'll
can do
come
it.
to that. I'll tell you
Like
why I'm
it would
doing
be,
it
sir,
this way.
it would be, ma'am, easier, I guess.
For quadratic, you can do it this way, but after this, we'll do even more complicated ones. So for that, first I'm discussing the easier one this way.
Okay.
Yeah,
This thing is x minus 1 greater than 0, and x, you need to find x such that x minus 1 is greater than equal to 0 and x minus 2 is also greater than equal to 0. This gives you this thing, and this gives you this thing. So I can just combine these two and write x greater than equals to 2, right? If x is greater than equals to 2, then it's obviously greater than 1.
yeah.
So this is the condition that you get on x. And from here, you do the same thing. So you get x less than 1 and x less than 2. And you can combine these two as just x less than 1, right? So you will get x where x is less than equals to 1. So from this case, what happens is you should take x such that either this thing is 0 or x such that either this thing is less than 0, both of them, right? We have an or here. You can just combine these two sets. You can take x greater than 2, then both the factors will be greater than 0. Or you can take x less than 1, then also both factors will be negative. So the whole multiplication thing will be less than 0. So your domain is going to be, what's the domain? This thing, right? Now you're taking, or you can say, call it this way as well. Same thing. From here you get this. You can write it as this. Is this fine?
Yes, ma'am. Ma'am,
Yes.
I
Yes,
have.
ma'am.
Yeah, ma'am. Ma'am, just once you can
Ma'am,
scroll
we are
up.
just
I'm
removing
just
those.
scroll up. I
बोल
will take the screenshot, ma'am. Could you please scroll up? I want to just take screenshot once. Ma'am, excuse me.
Yeah.
Ma'am, could you please scroll up? I want to take the screenshot. Ma'am, a bit more. Please scroll up.
Is it fine now?
Yeah, ma'am. From here it is starting.
Yeah.
Okay, ma'am. Once now, please scroll down. I've taken. Thank you, ma'am.
Ma'am,
Yes.
ma'am, actually, I am not getting the online lectures of other subject like this subject, mathematics and English. I am getting the online lectures, but I don't get the CT and statistics live lectures. It is not showing in my calendar. Whom should I ask to solve this problem?
Go to 0 week, and there is instruction to add the calendar.
In the particular subject, like in statistics and
And
CT.
I was also facing the same problem. Then there is 0 week mentioned. Go there and you will get before week 1. There will be 0 week. Okay, and add on that calendar.
Okay, okay. Thank you.
Okay.
Ma'am,
So, yeah, from the
ma'am,
graph also you can see. Yeah.
ma'am, and the domain of a function under root x minus 1 and x minus 2, we are just removing those points which gives
Negative
negative value to
values.
the
Yeah. This is what you're
yes.
removing.
Okay, ma'am.
Okay, so let's do this one this time. Let's say you have this. So if you want to find the domain of this, we know that this is always what you need to make sure is what we're doing is we just want this thing to be positive. If you have realized it so far, we just want this thing to be positive, right?
Yes,
This
ma'am.
innermost thing. So
Yeah,
this
ma'am.
is already positive because it's square. This is also already positive because it's power 4. So you just need to make sure that this is positive. So the domain should be x minus 2x such that x minus 2 is greater than 0. Or in some simple words, you can say from 2 to infinity, right? So this should be your domain. Now in this one, you can't plot. You don't know how, or if even if you know, sometimes you might not be able to plot things. Although you can plot it, we've done this thing, right? You can do it by plotting too, if you want to. But this one's just easier. You don't need to plot it. You just need to find that the points where your x minus 2 factor is positive. Is this
Okay,
fine?
it is fine.
Yes, ma'am.
Yeah, ma'am.
Okay.
Ma'am, excuse
So,
me. Here, one more thing. Just,
yeah,
ma'am, may I ask?
yeah.
So here, what is the domain of f and what's the domain of g in this case?
Okay, your domain, if you're taking this function to be FOG, then your f is going to be square root of x again, and your g is going to be this innermost thing, right? So domain of g is going to be domain of g is going to be r. And then you do that thing x such that gx is in the domain of, which gives you this only.
Gx is in the domain of it.
Yeah. This thing is going to give you this.
And the domain of FOG is 2 to infinity only.
Yeah, that's what
Okay.
I've written here.
Okay, ma'am.
Just once
Okay.
scroll up just one type, please. Not that much. Ma'am, just one more thing, that why that domain of f is equal to root x and domain of g is x
This is
minus.
not domain, this is the function. Domain is x greater than 0. This is just the function, square root of x.
F is equal to, yes ma'am, that was that way I was asking, that f is equal to square root of x
If you
and
have this thing, let's discuss it from here.
uh,
One function that we clearly see here is the square root x. Okay.
no,
In fact, what you can do is one is clearly the square root,
square root
other
of
one is
x.
multiplication. So you can extend it further to what happens is right now we've simply taken 2x plus 6, but you can also write 2x plus 6 as the composition of two functions. Where you can take g dash to be 2 times x and f or f dash to be x plus 6. So if you will take this and you will take g dash composed with f dash, you're going to get 2x plus 6, right? But we
So
don't need this because this is going to give you same domain. There's no point extending it into f dash then g.
so I was exactly asking that how that g dashed to x, what does that mean exactly?
You just need to find because this is the main function here. Even
Root
if you
of it.
don't do it this way, the problem is 2x plus 1 is not creating any problem because you can put anything here in this one. The problem is with the square root.
Yeah, square root
So
is
for
f.
this, you need 2x plus 6 to be greater than 0. You don't have to write that entire thing. You can just do it from here. X such that your 2x plus 6 is greater than 0. Because otherwise your root function is not defined. And from here you can get x greater than equals to 6 by 2 will be 3 minus 3. If you don't want to follow, sometimes when you have lot of functions f, o, g, o, h, then this formula helps.
Which formula?
The formula that we did initially, when you take domain
Oh,
of
okay.
this one, it will be domain of g, then intersection x such that your domain of h first, innermost first, domain of h, then such that your hx is in domain of g,
Domain
and
of g.
intersection with x
So is that
such that
g of x, g of h of x belongs to domain of f.
this helps then. And even
Yeah.
if you don't want to do it, just make sure that the functions that you've applied, like this one, let's say if you've taken e to the power x square minus, let's take x plus 2, e to the power x plus 2 square root, just make sure that everything, now this is a composition of a lot of things. E is there, square root of is there. Just make sure every function that's there, e to the power x is, you can see, square root, this is defined. That's all.
Yeah.
If you get confused, then it's better to use this formula. Otherwise, you don't actually need this one. You just need to check all the functions involved should be defined. That's all.
Okay, ma'am.
That's where you get this formula from. Okay. And coming to the inverses, that's the last topic. So inverses, let's say you have to define the inverse of a function
Ma'am,
denoted by f inverse this. Yes.
can we take an example that we are talking about? E to the power under root x plus 2. The domain of this function is r or r minus 2, r minus 2.
The domain is just it's x plus 2, right? So x plus 2 should be greater than 0. That will give you x greater than equals to minus 2. If this
Then
was your
it should be
function.
r minus 2.
No, it's this minus 2 to infinity.
I cannot understand that e to the power root x plus 2.
If this is your function, it's a composition of a lot of things, but E actually doesn't make any difference because the domain of E is all R, right?
Okay.
That's not going to
Yes,
make any
ma'am.
difference. You can skip that part. Just focus on square root of x plus 2. You need this thing to be defined. This
Then
thing,
x plus
you
2
need
should
this
be
to be,
greater than equal to
yeah,
0.
this part should be greater than 0. And then just solve it for x. So you'll get x greater than equals to minus 2, which is the same. So it should be x such that your x is greater than minus 2, which is the same as minus 2 to infinity, right?
Okay, ma'am. Thank you.
We're coming to the inverses of a function. First thing
Yeah.
that you need to know before knowing the inverse and all is for inverse of f should be 1, 1 and onto. In fact, it's an if and only if thing. Let's just define inverse first. What is inverse of f? Inverse of f is, it's denoted by f inverse. It's a function g such that f composed with g and g composed with f gives you just x. So if there is a function g such that f o g x and g of x is x, then it's the inverse of f. Then you say that your g is f inverse. This is the notation for inverse of f.
So in inverse as the range and domain that get change actually. The change. The
What?
range becomes the. I am saying that in the
Yeah,
case
yeah.
of inverse, the
They
range
get
becomes the domain.
interchanged.
They
And the
become the
domain
domain,
becomes the range, right?
and the domain becomes the range.
This is the definition of inverse of a function. And for a function to be invertible, invertible functions are the functions whose inverse exists. There are some functions whose inverse does not exist. For example, these functions, x square plus the quadratic function, because whose inverse exists, and there are functions whose inverse does not exist. For example, the quadratic functions. Inverse of quadratic functions does not exist.
Because quadratic functions are not one.
Yeah, they're not 1, 1. And this brings us to the point that for a function to be invertible, for f to be invertible, that's only possible. Let's just write f is invertible.
Excuse me, the YouTube link here in the calendar is not available.
Someone please share the YouTube, the link of the YouTube channel, please,
मैं
in the
यूट्यूब
chat
में जाके
box.
ढूंढ ले.
This is it. So f is in, so this is if and only if. If and only if means if your f is invertible, f should be 1, 1 and onto. And if your f is 1, 1 and onto, then it should be invertible. For example, let's just take a simple example. Let's take fx equals to 3x or 2x. Taking x makes no sense. So if you have 3x, then what should be f inverse of x? How do you find? Let's just say I'm giving you a simple formula to find the inverse of a function. Let's say you have been given fx equals to y. Then what you do is, now here you have y in terms of x. That's how you write functions, right? The function is in terms of x. So what you do is you write x in terms of y. For example, let's say you have function 2x. So you write here you have been given y in terms of x, write x in terms of y. So x will be y by 2. And then just take this function. So this function is the inverse. Just remove y and take x by 2. So if this was your function fx, then your f inverse of x is this. And you can try composing these two. If you'll compose them, you will get you'll compose x by 2 and then you'll put it in 2x function.
Wait.
It becomes x. And similarly, if you'll do 2x and compose it with the x by 2 function, you'll get x again.
Ma'am,
Let's take one more example. Let's take y is equals to 2x plus 7. So if you have 2x plus 7, what you do is, right now you have y
minus
in
7
terms
by
of
2.
x. Write x in terms of y. Get y minus 7 by 2. And then your inverse, if this is f, then f inverse x is x
X
minus
minus
7
7
by
by
2.
2.
Let's do one
Ma'am,
more.
just last example, just the last example. I want to take the screenshot. Just yeah, the
ma'am,
above one, ma'am. Just last to last. Yeah. Uh, okay, ma'am.
can you please explain last example? I am not getting it.
All you do is, first you have y is your function, right? This is fx.
Okay.
Where fx is 2x plus 7. So you write x in terms of y. Right now you have y in terms of x, right? So you take out x from here, separate x, write x in terms of y, like this. And then because the inverse is going to be a function of x only, replace y by x. That's all.
Yeah.
Let's take up another example. Let's take this one. So if you have this as fx, so what you do is, first you equate this thing to y and try to find x in terms of y. Right? You'll get x plus 1, yx minus y. Take this thing here.
Yx minus y.
This becomes 1 plus y and y minus 1. So you have written x in terms of y. Now your inverse is going to be
1 plus
replace y with x. So you'll get x plus 1 and x minus 1. And this was the function initially, right? So the inverse of this function is this function itself.
composite it. Composite.
You will take x plus 1, x minus 1. Replace x, you will have this thing. You'll get x plus 1 plus x minus 1 by x minus 1, but it gets cancelled from here. So it will be x plus 1 minus x plus 1.
X
This is
minus
going
1.
to be,
X plus 1.
this just gets cancelled. So it's this is 2x by 2, which is x. Composition gives you x only.
So, ma'am,
Ma'am,
what?
this value where we put it, x plus 1 upon function of x, कहाँ पे put करना है मैम?
What?
Ma'am, this is a composite function of what? Is it a function FOF we found here?
Yeah, this is FOF because your f inverse is f only. This is f composed with f, which you get as x. That means f is the inverse of f. And what happens when f inverse is equals to f? Okay, we'll come to this one later. If you have f and f inverse, and if you plot the graph of these, so what happens is, let's first draw the line y equals to x. Let's just say this is the line y equals to x. So if your f is like this, If this is f, then f inverse is its image about this line. So consider this to be a mirror, and then your f inverse is like this. Is it fine?
Yes, ma'am.
Okay. So, for example, okay.
How you write
Write
x
what?
plus 1 upon x minus 1. And this is x plus 1 upon x minus 1 graph.
No, no, this is not, this is a random function.
Oh, okay. This is inverse function. So symmetry बीच में और वो
Yeah,
mirror image है दूसरी.
Ma'am,
this is
suppose
the graphical importance of G and G inverse. How do G and G inverse look in while plotted graphically? So that's what
ma'am,
we're discussing. Yes.
ma'am, if f of inverse is equal to f, what is the special cases here? Like you said,
If your f inverse is equals to f, then your function is going to be same. So it means something which when reflected about y-axis gives you that function only. For that, you'll need to plot this thing. You'll need a function whose inverse like x. So if you have fx equals to x, the inverse of this function is x whole. No, it's 1 by x.
How, ma'am?
ma'am, we can take the example from the last slide only that we found.
Wait,
F
wait, wait. It's x only, right? Wait. If you need, yeah, the inverse of this is x only. Or is it, wait. You have fx. When you'll compose fx with f, you'll have x. Yeah, it's x only. It's x. So what happens here is this is a line y equals to x. And then the function you've also taken on this line only. We said that
It will
if
overlap.
f is a function here, yeah, it's overlap. It's on this line only. Your function is this line itself. So if you want to take the image of this, you can't actually take the image. It will be this only.
That is fine, ma'am. But if there is a little complex function because f x is equal to
I
x, we can.
cannot think of something right now.
The last one we did in the second slide that we solved.
I can't plot it. I don't have tools to plot this one. You can try it in some uh, Desmos or something and then check. Okay. So and then and so what happens is you know that this is reflected about this point and the only point that lies on both f and f inverse. So if you talk about point of intersection of f and f inverse, then the only points that are both on f and f inverse. That means if you have this as f and this as f inverse, then the only points that are going to be both on f and f inverse are the points on this line, y is equals to x. So the point of intersection of f and f inverse lies on y is equals to x line.
Ma'am, we always get only one intersection point.
So we can get more than one. We can have something like this.
All the intersection points will lie on the line.
Yeah.
Is that right?
All the intersection points are going to lie on this line.
And always passes through origin.
With yeah, y is equals to x always passes through origin, no? And one more thing about inverses is that if your AB lies on F, this implies your BA lies on F inverse. That's all. I think we've summarized everything that's in week 5. If there's anything that you want to ask, you can. Otherwise, we can end the session here.
Ma'am, the quiz one that happened, the answer key we got it. So in the answer key, I didn't able to find the which question I have tick right and which wrong. Is it same for everybody? I just got what are the right answers. But in the answer key, it should be mentioned that which, like, what option I have corrected it or not corrected it.
The
Is there?
result is already out.
Yeah,
Yeah,
but
just
in terms of
I'm
answer
not.
key, the result will be
I
out.
don't handle that.
So in the answer key, would you be able to find your correct answer and wrong answer with answer key?
I think in the answer key, you'll only be you'll only be given answers.
Answer transcript will be given. You can find it on documents for download. From there, you can match your answers.
And the result link
And
what will be?
you said where I would be found on the dashboard, like
Yeah, on
what option?
dashboard, there will be an option documents for download. So there you can find the answer transcript.
Okay, documents for download. Okay.
Yeah, ma'am, I just have a request. Uh, so, uh, so are you
Yeah.
there, ma'am?
Yes.
And can I speak in Hindi, ma'am?
Yeah.
सो मैम क्या हुआ ना, ये मेरा क्वालिफायर था। तो इसमें मतलब मेरा जो सेंटर था, मेरा वहाँ पे मतलब अराउंड 1.5 घंटा बाकी था। तो वहाँ पे सेंटर में जो इन्विजिलेटर्स थे, तो वो खाली हो गया पूरा एकदम से, मतलब मैं ही एक इंसान था वहाँ पे। तो वो लोग
सेम
ऐसे
मेरे साथ
मुझे,
हुआ।
हाँ, तो वो लोग ऐसे मुझे फोर्स करने लगे कि जल्दी इसको खत्म करो, जल्दी इसको, मतलब एकदम गुस्सा होके गाली भी देने लगे वहां पे। तो वहां पे मेंटली मैं बहुत डाउन हो गया था, और मैं पूरी तरह से प्रिपेयर करके गया था। मेरा मैम जो स्कोर है ना, वो बहुत ही अच्छा आया है, मतलब सीटी में 100, स्टार्ट में 100, मैथ्स में 94 आया है। तो और लास्ट मोमेंट मैंने इंग्लिश को किया नहीं था, उसको लास्ट के लिए रखा था। तो उसमें मैंने ऐसे रैंडमली ऑप्शन सिलेक्ट कर लिया था उनके प्रेशर की वजह से। तो
Okay.
ये मैं नहीं चाहता हूँ कि और किसी के साथ हुए, मतलब हो जाए जो सेंटर में इन लोगों का ये जो बिहेवियर है ना, ये थोड़ा सा मतलब चेंज होना चाहिए। और मैं इस चीज को लेकर बहुत ही दुखित हूँ, मतलब दुखी हूँ इस चीज को लेके, जो भी चीज हुआ है मेरे साथ। तो ये थोड़ा सा आप अगर जो भी अथॉरिटी ये सब संभाल रहे हैं, उनके 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 तक अगर आप ये मैसेज पहुंचा सकते हैं तो
Yeah.
वो अच्छा
Okay.
होगा। और मेरा सेंटर था मैम संबलपुर उड़ीसा में।
Okay. I'll convey it to them.
ओके मैम, एंड संबलपुर में एक ही सेंटर होता है, और वो समझ जाएंगे, मतलब जो भी चीज़ था
Okay.
वहाँ। जी मैम।
You can also write an email on the support and
Yeah.
या आई हैव ऑलरेडी रिटन, नॉट गॉट एनी रिस्पॉन्स। एंड मैम वहाँ पर एक मतलब कोई एक थे बीएस डिग्री का भी कोई एक, मतलब मुझे नहीं पता वो कौन थे, बट वो आईडी कार्ड में उनका बीएस डिग्री मेंशन था। बीएस डिग्री का भी कोई एक थे वहाँ पे। तो दैट्स इट।
Okay. I'll speak to whoever
जी मैम।
handles this.
जी मैम,
Okay.
मैम मैंने मतलब बहुत ही मेहनत किया था इस चीज़ को लेकर, और एंड में मैंने फेल हो गया। इंग्लिश में मैंने अभी फेल हो गया हूँ, जिसकी वजह से
I
मुझे फिर से ये
understand.
देना पड़ेगा। मैं ये टाइम को भी ऐसे वेस्ट करना नहीं चाहता था। लिटरली मुझे अभी रोना आ रहा है इस चीज़ को लेके।
Okay.
ये
I understand.
मैम
I'll.
आप ही
रिजल्ट तो अभी
बताइए।
आया नहीं है।
रिजल्ट आ गया
It
है
to
क्वालिफायर
authorities.
लोगों के लिए। मैम आप ही बताइए, सही है
अच्छा
क्या?
अच्छा।
वहाँ पे इन्विजिलेटर का इस टाइप का बिहेवियर सही था क्या? वो लोग मतलब ऐसे, मैं
नहीं,
एक ही था वहाँ पे स्टूडेंट, और वो लोग ऐसे कलेक्टिवली आके, मतलब ऐसे ग्रुप होके मुझे फोर्स कर रहे हैं। सबके सब फीमेल ही थे वहाँ पे।
Yeah, okay.
वो,
I understand this concern,
और
and you
मैंने
just.
मैंने उनको बताया भी मैम कि टाइम तो है मेरे पास, मुझे करने दो। फिर वो लोग ऐसे मेरे पास में ऐसे ग्रुप में बैठ के शोर मचाने लगे, मतलब आप अपने आप में
ये
बात
तो
करने
भाई वो
लगे।
डायरेक्टर सर के पास मैसेज कर दो, मेल कर दो, तो रिप्लाई जल्दी आता है।
पर
जी जी।
एक्चुअली
I
इंडिया में
did not
कुछ ना
received
कुछ,
any mail
Okay.
with the answer sheet.
आप तो भाई लड़ मर जाते हैं वहां पे, कुछ होता नहीं ज्यादा मुझे लगता है।
हाँ बट
हाँ
Let's
मतलब हम
मैंने
गुस्से
कोशिश किया था मैम,
क्रिएट
मैंने
गुस्से
कोशिश किया है
पोलाइट
कि
होके
उन
बात कर
लोगों
रहे
को
let's
थे।
end
इग्नोर
the
करूं।
session here, guys. It's really not a place to discuss this thing.
यस यस यस
Um.
मैम, ओके मैम, बट मैम
Okay.
प्लीज
I'll,
आई मीन
yeah,
टेक
yeah,
दिस
I'll make
मैसेज।
sure to
Okay.
inform
Thank
the
you.
authorities about this. Okay.
Okay. Thank you so much, ma'am.
एक मैम का नंबर है मेरे पास.
Okay. Thank you guys for
Thank you,
joining.
ma'am. Thank you, ma'am.
We'll end the session
Thank you,
here.
ma'am.
Thank you, ma'am. Good night.
Good night, ma'am.
हेलो, वी हैवी
हाँ.
मैं पूछ रहा हूँ कि वो
क्या
क्विज वन का रिजल्ट आ गया है? अरे
यार,
शिवू
अभी
भाई,
तो मेरे में नहीं दिख रहा, मेरे
आप तो
डैशबोर्ड
शारदा
में
में
यार.
हो,
यार वो आंसर की आपने
मेरे
चेक
तो
किया
डैशबोर्ड में भी नहीं दिखा रहा।
किसी ने आपने चेक किया क्या आंसर की कि कौन सा आंसर आपका सही गया है गलत गया है? आंसर की तो बोल रहे आ गई है.
पर
रिजल्ट ही आ
आपको
गया
कैसे
भाई,
पता
अब बोल
चलेगा
के
आपने
क्या
कौन सा
फायदा।
ऑप्शन लगाया था?
यार
रिजल्ट
बहुत जल्दी बंद होने वाला है, कोई लिंक शेयर करो टेलीग्राम वगैरह का यार, उस पर बात करते हैं. जल्दी बंद करो, जल्दी मैम वो कर देंगे,
वेट वेट
एंड कर देंगे सेशन.
वेट मिनट वेट
जल्दी जल्दी,
वेट मिनट
जस्ट
वेट
जस्ट टू.
मीट
वैसे
मीट
आज
मीट
मैम
मीट
ज्यादा
मीट न्यू मीटिंग
आप लोगों का कितना है भाई लोग?
ज्वाइन नो
अभी भाई रिजल्ट ही नहीं
रुको
आया है
रुको रुको,
भाई.
मैं शेयर कर रहा हूँ, उस पर बात करना।
यार
क्या
मेरा
हुआ?
खुद का
लिंक
मैथ छूट
टेलीग्राम में
गया
शेयर
यार
कर
थोड़ा.
दो.
एक दो क्वेश्चन मेरे भी, 3 क्वेश्चन
यार
मैथ्स के
मैथ
छूट
टफ
गए.
था यार. मैथ टफ था यार. मैथ मुझे वैसे ही टफ लगती है यार, मैथ टफ था.
यार मैथ्स के कुछ
आज
क्वेश्चन
का
जो थे ना
सेशन भी
थोड़े
बहुत टफ था भाई।
मैथ शुरुआत
तो
के स्टैट भी शुरुआत के क्वेश्चन काफी ट्रिकी थे यार, पिछली मतलब जो पीवाईक्यूज थे
सब
वो
लोग इस पे
काफी
आ जाओ,
आसान होते थे.
इस पे आ जाओ,
मीट मीट पे, या मीट पे.
मीट पे आ जाओ, हाँ आ जाओ।
ये कॉपी नहीं हो रहा यार, ठीक कॉपी कर लिया. ओके.
मैं मीट पे हूँ, मीट पे आ जाओ,
कॉपी
ठीक है।
लिंक.